Hello, welcome. Let's try to solve another Leetcode problem. 1007 minimum domino rotations for equal row. So let's first try to understand the problem. Yeah. So for the first example, we can check the drawing, and in this drawing, yeah, we can just rotate this one. We can just rotate this one and rotate maybe this one, and then the top. On the top, it's gonna always be 2, and how many rotations it's gonna be 2, and we just need to return the minimum rotations. Yeah, or maybe we can rotate, make the bottom to be 2, but that is not the minimum. If we make the bottom always to be 2, it's gonna be 3, but 2 is the minimum. Yeah, and let's just check the second example. Let's just make a drawing. Maybe this will be easier for us to understand. So we have 3, 5, 1, 2, 3. This is our top, and our bottom is gonna be 3, 6, 3, 3, and 4. So first of all, can we use a brute force to solve the problem? I mean, how many numbers for this dice? Definitely it's gonna be 6 numbers. Yeah, because for dice it's gonna be from 1 to 6. If this is okay, we can even use the brute force to solve the problem. But actually, we don't need to use that. Yeah. So this is just for a dice. Maybe we are just giving 2 arrays, and this array can be rotated to another array. Yeah, if it is not from numbers 1 to 6, definitely we cannot use the brute force. Yeah. So now let's just use another idea to solve the problem. Definitely, it's not brute force. Let's just check the top I and bottom I. So it is from 1 to 6. So this means we can use the brute force. But we don't need to use. If the top I and bottom I is not from 1 to 6, it may be from just 1 to 10,000. So what are we gonna do? If this is not the domino, yeah. If the point is not from 1 to 6, yeah. So because we are going to check half of the numbers. How many numbers? We're gonna check half of the numbers, which is gonna be this number. So maybe for this number, for the first example, it is a 2. So we are just count how many 2s. It must be so the number of 2 must be more than and equal to length of the tops array or bottoms of array. So if the length of the array is n, so the number of 2 must be more than or equal to n. So this is the idea. Now let's just check the second example. So for the second example, we're gonna check what's gonna be the most frequent number for the top and bottom array. So we're gonna put it together. So definitely it's gonna be 3. 1, 2, 3, 4, 5. Yeah, we have 5, 3. So for this 3, how many is 3? We're gonna have 5. But is this okay? Actually, it is not. Yeah. Yeah, because at this precision, this is 3 and 3. This is 5 and 6. Definitely, it didn't work. But definitely, if it is possible, it must be 3. Yeah. I mean, all the top or all the bottom must be 3 after rotation, if it is possible. But now it is not possible because this is 5. This is 6. Yeah. So this means, first of all, we're going to combine the tops and bottom, and we're going to check the most frequent number. So for this example, it's going to be 3. And then we're going to check this number 3. For the first example, we're going to check this number 2. Yeah. So for checking this number, we can rotate all the numbers to this top, to the 2. Or we can rotate all the numbers to make the bottom to be 2. Yeah. And then we're going to choose the minimum. So this is just the basic idea. Now let's just start coding. So we're going to prepare the length of the tops array. So this is okay. Now we're going to prepare a counter. So the counter is going to be the tops plus the bottoms. Now we are going to check the most frequent value. So we're going to set the value as 0. So for kv in c.items. So we're going to check the most frequent numbers, so how many of them. So if this way, if the numbers are going to be more than and equal to n, so this means we've already found it. So we're going to find the value. So we're going to set this value to be k. K is just the number. For the first example, it's going to be 2. Yeah. Now let's just check the final result. We're going to prepare two variables, result and answer. Now we're going to check all numbers. So for a, b in zip on top and bottom. Yeah. So we're going to check one by one. So if a not equal to our value and b equal to the value, now we're going to prepare the top. So the top is going to be result plus 1. And if a equal to the value and bottoms b, it is b not equal to the value. Yeah. So this means we're going to rotate this dice and make it bottom to be this value. So answer gonna plus equal to 1. Another case is if a not equal to this value and b not equal to this value, so we're gonna return minus 1. This means it is not possible otherwise. So we're gonna return the minimum of the result and answer. Yeah. Now let me just run it. This is a zip. Yeah, now as you can see it works. Now let me submit it. Yeah, as you can see it works and it's pretty fast because the time complexity is just ON. Yeah, so it doesn't matter how big is the top I or bottom I, it doesn't matter because definitely we are not using the brute force. Or maybe we're gonna use some better variables. Maybe we're gonna use top, maybe. Yeah, we're gonna count how many tops and how many bottoms, so maybe this is better. Yeah, so we're gonna put the result to be top and answer to be the bottom. Yeah. So this is for checking if all the numbers. This is for checking if this number, if it rotates the number to the top. So how many tops and how many bottoms. Yeah. And we're gonna choose the minimum count. So I hope you understand it. So basically, this problem is just about mathematical calculation. If you know about some mathematics, definitely you're gonna solve this problem. Thank you for watching. See you next time.